All right, so what we have here is some code which basically simulates flipping a coin 250 times. So I import my library random here, make the number of heads 0, and then I go through my loop 250 times, and every single time through my loop I pick a random number between 0 and 1. If the number is bigger than 0.5, I assume it's heads, and I add 1 to the number of heads. And then when I'm finished going through my loop, I'm finished flipping my coin simulation 250 times, I simply print the number of heads. So if I run this program, I got 125 heads that time. I can run it again. I got 119, 116. I can keep running this program, and I get always somewhere in the neighborhood of about 125. I don't get exactly 125 every time, but it's in that neighborhood. Now what I want to do is build on this. I actually want to run this entire experiment several thousands or hundreds of thousands of times. So what I want to do is abstract this process. So what I'm doing here in this highlighted region is I'm simulating one trial of flipping a coin 250 times and figuring out how many times it landed on heads. So I'm going to create a procedure that does this. So the way to create a procedure is you start by typing def, so that's like define. So we're going to define a procedure, and it's going to be called run trial. So this is going to be our procedure which runs a trial. It doesn't have any parameters, so the parentheses are blank, but you have to have the parentheses there. And I'm going to put a colon. And then everything that's part of my procedure is going to be indented. So what you can do is highlight all of this and then hit the tab key, and that'll indent it. So this is all part of my run trial procedure. The other thing that a procedure's got to do is it's got to return. So in this case, instead of printing the number of heads, I'm going to return the number of heads. So that sends it back to wherever the procedure was called. So what I've done is I've turned my code, which simulates a trial of running 250 coin flips, I've turned it into a procedure. And then what I can do down here is I can use my procedure. So for example, if I can do this, I can say for x in range, let's run this entire thing 10 times, which would have taken you forever in class. But I just want to say, hey, the number of heads is going to equal run trial. And so that is a call to the procedure. It's going to go run the procedure, which is called run trial. And then it's going to return the number of heads we got out of those 250 flips. So that's going to be make it equal to h. And then I can print h. And then if I run this, then 10 times it did the experiment. So what I did was I abstracted this entire process of flipping a coin 250 times and counting how many heads. I abstracted that as a procedure called run trial. And now I can just use that procedure. And the reason this is nice is because now I can click right up here next to where it says def. There's a little minus sign, and I can hide all that code. Okay, it's like in Snap when we made a block. I've tucked that code away, and so now my code is a lot simpler to read. So we have a loop, and each time it's going to run a trial. The trial flips a coin 250 times, figure out how many heads there are, and then we print that. And then so you can take your code, which flips your coins and figures out how many heads there are, and you can abstract it using a procedure. And then you can call the procedure here, and whatever it returns gets stored there in h, and then you can do whatever you want with h. For example, you can count how many times the trial yielded a result that had more than 138 heads, for example.